I am Muhammad Afif, and people usually call me just Move It, and it is also my Twitter handle. And please don't follow my Twitter because usually I tweet cats. If you don't like cats, please don't. And I am racing since 2012, and actually I'm doing it professionally since 2015. And I work on company named Pintar. It's a SaaS platform company, and we also build for IoT devices. And yes, we deal a lot with devices. And thank you very much, guys, to RubyConf Committee 2017. Give applause to them because they can make this conference happen, the first RubyConf Jakarta. I'm really, really excited. I'm really happy can talk to you guys. All right. So today, a lot of people talk about performance. A lot of people talk about performance because, well, you need to acquire more customers. You need to acquire more users. And if you acquire more customers, you need more servers to serve more users, of course. But yeah, that's why performance is important, and people all the time talk about performance. But more importantly than performance is the correctness of your program. So imagine you have a program that have a bug, and you only have 10 customers. It's rather simple to solve that. Perhaps you just reach your customer one by one, and hey, I'm really sorry, our program is buggy, and all right, yeah, something like that. But imagine you have thousands of customers, millions of customers, and it will be very, very catastrophic if your program is not correct and you scale up your program. So performance is important, but correctness of your program is more important. So, all right. And today we are talk about very, very specific problem of correctness of your program. That is stress condition. But what is stress condition anyway? Actually, some of you guys perhaps have this concept in Udacity or in your campus, but in industry, perhaps it will be very, very different if we see that in practice. So what stress condition? Stress condition is kind of distress condition. Perhaps not. All right, that's not kind of race, but all right, it's not a Formula One race, or perhaps a motorcycle race. Of course not too, of course. I'm not kidding here. And perhaps race condition, you guys really, really love into code. You really love your laptops, right? So you really love code. So perhaps race condition is something like this one. Of course not, this is RESTful. It is HTTP, all right. So what race condition is, so instead of I tell you what kind of problem is that, I will show you an example. It's available on GitHub. You can test it by yourself. So I really love this bank. I name it Sementara Bank in Bahasa Indonesia. It's temporary bank actually in English. Sementara Bank is our dream of bank because you can add any deposit you want without actually having money. Yeah, I really love this bank. And I have $5,202 in my bank, and I can deposit any amount of money to my bank. So imagine depositing your money is as simple as clicking button without actually having money. And yeah, it's really fun. I can get rich in just 5 minutes. All right, so let's see. Let's try, let's try press this button, this left button. And the server is processing, and wait a minute, and boom, it's done. Now it is $5,207. It's expected, right? There's nothing wrong with this bank. All right, but there's some button over there, the right button. What is this button? So it is basically pressing the left button 10 times, as simple as that. It should work fine, right? It should work fine. It should be. because just like tapping elevator button 10 times, that should be nothing wrong with that. So all right, so let's try pressing that button. We take note our previous balance is $5,207, and it's the server processing, boom, $5,232. This is from a real world example, and this might happen to your application if you are not doing it correctly. And all right, if we press the button 10 times, it should add $50. But it's not. It's $5,232. So where is the other $25? All right, this is the problem that we want to talk to you about right now. So what kind of that bug is? So, all right. The program is just as simple as this. That we see peek into the program, and it seems like there's nothing wrong with this program, right? All right, so we will take a look into the program deeply after this, but we will see from the Wikipedia words. So it's pretty much a long definition, but we will highlight some important words there. So your behavior, output of your dependent sequence, and timing of other events. And it becomes a bug when events don't happen in the order of the programmer intended. So let's go back to our lovely program. It's just 4 lines of program, but it has some things that we must solve. So let's try it, running it line by line. Let's say we have initial balance of $100 and the amount of params is $5. All right, so let's try this. We'll try to verify the request, CSRF, and something like that. And there should be nothing wrong with that. And it will try to find the current account, and it will add the balance. But please take note that when you add balance like this by using addition like this, it is not yet stored in database. It will be stored in database when you press when you execute the save command. And now after the command executed, it becomes $105. So seems like there's nothing wrong with this program until we know that actually we run this program today not in single servers or single threading. REST 5.1 by default using Puma, and Puma is multi-threading by default. So that means that your program might be executed in the same time, and perhaps there will be more than one routine or one function running at the same time. So if the program is executed in parallel, let's say you have multiple processor, multiple threading, or even you have multiple machine in running behind a load balancer, perhaps this become like this one. The program is running. And suppose, but let's take note too that you cannot control the sequence of your program, because there's some processor scheduling mechanism in operating system that you cannot really control what will program run. So it might run in parallel like this. So it run 2 requests at the same time. It read the same record at the same time. It add the balance at the same time, and it try to store the database at the same time. If this condition occurs, what will happen to our lovely account? It will be add to $110 or $105. We will never know, because this is really uncontrolled situation. Anything can be happen. But this is the condition when it run in parallels and line by line, but actually you cannot control how the program will works. It can be like this one, or it can be like this one, or it can be like this one, or it can be like this one. You cannot really control what operating system, how operating system will execute your program. So, but this is because there's something called atomic operation. So atomic operation is something that your program or your line or your methods is guaranteed done without interruption. But we can try to minimize the problem like our previous problem by making everything is atomic. But it is really, really hard. So, but perhaps, okay, well, we cannot make the program atomic. So how about making the program just one line? So, well, that's not how you solve rest condition. Even you try to make one line controller, you can't do that, and rest condition can still happen because inside that program, perhaps there's some assembly function, or there's it calling another library, or it do some process in framework. So atomic is not equals to one line. And we never know what kind of atomic operation is until we see the documentation of the program, because every implementation might be different. But before we go into that things, perhaps we need to see when your programs read something or write something. You must know the desired action of your program. So, what our desired action if on this program is adding an amount to an account. So it should be as simple as that. So now we have the desired action. But our desired execution is something like this. If this thing happen, it will not intersect each other, so that it can add the amount to that balance without any problem. So we need to achieve this behavior. We need to achieve this behavior. So when we're reading and writing, it shouldn't be interrupted. So, but we don't want this execution, because take a look at the red lines. It will read a data that is being written. So this is not something that we want. It's tried to add the same amount, but it is actually not. You may read a file that is being written by other. So be very, very careful when doing this one. When you are trying to read something, or when you are trying to storing something. So read and write at the same time must be atomic. And we know something called lock. Locking is something that allows a program to hey, I need this resource, and the other program or the other process shouldn't access this resource. And gaining lock considered atomic, so it is guaranteed that there's no other process will gain the same lock for the same record. And hopefully and thankfully, there's built-in lock mechanism in Rails. There's two types of locking. There's pessimistic locking and optimistic locking. Let's start with pessimistic one. So pessimistic locking requires transaction, but it guaranteed the other's process can't read the data until transaction is done. And it's less likely to be failed because it's wait. So for example, this is our program without transaction. Take a look on the lock keyword here. It will lock the specific record, and it's guaranteed other can execute this fine. It will wait. So let's see this in action. It will try to verify the request, and it will do some transaction. And all right, even locking happen at the same time, only one process or one thread or one machine that will gain the lock. Let's say the process on the right is gaining the lock, the left will be blocked. And process on the right can continue adding the balance and saving the balance. And it's persisted in the database. After it's persisted in the database, the lock is released, and the other process can continue storing the database, and our program can work correctly. That's pessimistic locking. Well, how about the other one, optimistic locking? Optimistic locking doesn't need transaction. It doesn't block. But it can fail if it detects rest condition. Optimistic locking in Rails happen by only adding a column lock version, and it will automatically make the model, the specific model, will be available for optimistic locking. Internally, Rails will execute something like this. So it's try to update record with the same lock version, and it will increment the lock version by 1 for each time storing the data happen. And it's guaranteed other process can't store the same record. So suppose we have something like the same program, it will. But when we try to, let's say now we have lock version 1. Of course, this is default when you the first time using optimistic locking with Rails. And when it try to save the same data, and it happened on the same time, only one process will succeed. And the other process, because the lock version is no more the old version. Lock version is previously 1, but there's no record with ID 1 and lock version 1. And active record will raise active record style object error. Because storing can be failed, optimistic locking must have a retry mechanism, something like this one. You can use retry as many times as you want. It depends on the critical level of your program. So you might be very, very careful when you are reading and writing your data. But actually, this is just one approach. For this case, we can write the data without actually reading it. For example, if you use the database, PostGRES, PostgreSQL, let the PostGRES lock themselves. Something like this one. Even we read a balance in this query, a single query in Postgres is considered atomic. So there will be no rest condition in this case. So this might fine too, but it comes with a trade-off. You must run a raw query in your SQL. It might be problematic for some program because it bypassing callbacks and it bypassing validations, and it is raw SQL. So be very, very careful, because if you are not doing it carefully, you perhaps will lose some security, and it comes something like SQL injection, something like that. So in my company, there's a unique case that I want to talk to you about. And our cases is we have multiple machines, but unfortunately we have bandwidth problem because the servers is spread across nations in Indonesia. So we cannot really give all the data at single request. It's a microservices, but we can't give all data to clients on single request. So we must paginate the data. But data pagination comes with its own problem. We call it data drift or something like that. So suppose we have data like this. We request on the page 1, there's data 1, data 2, data 3, data 9, and etc. And it's ordered by modified time when we call the first page seems there's nothing wrong with this. But when we try to request the second page, and suppose data 28 is changed, so it's updated, and now the page is no more in our desired data, because what we want is from page 1 to page to the end of the pages, all data should be kept intact, because we don't want to lose the data. We need to retrieve all the data, but we need to make it in pagination because of the bandwidth problem. So our case is just persist all pages at the first query and give it some transaction ID. So something like this: when we request the first page, we request a transaction, and the server will return something like tax ID. And when we request the next pages, as long as the transaction ID is different, the data on all of pages is kept intact as the first request and the same transaction ID. So when we try to request the first page and the second page, and there's nothing problem with that. So perhaps we will see some other cases and alternatives. So perhaps something like a serializable isolation mode is something. It will roll back if one query in transactions may conflict each other. It's some like pretty advanced concept, but it might fit your use case if you want to try. And if you don't want to use Postgres for lock, you can use the other. You can use implement your own lock using in-memory keys, or even file, or even you can just use RubyQ if it is on the same process. Now, let's talk in the interesting part how to mitigate the problem. So to mitigate the problem is just like we have seen in the last 20 minutes. You may want to draw your program, to draw the state diagram of your program, so you can understand how the data goes on. Or you want to draw the sequence diagram, so you can get better understanding how the data changes from one method to another method. So in short, you must understand how your program works, and perhaps on the multiple machine. And you may try to simulate slowness of your program using sleep 1 or sleep 10 or something like that. Or you may want to try running it line by line, just like what we do before. And you may also want to run a multi-thread test. It is possible. It's really possible to run a multi-thread test. And both in RSpec or a mini-test, it's really possible. But you may want to try some tests with some thread being paused. So in short, to get a better understanding to solve your problem, you must understand about how your own program works. And by understanding how your program works, hopefully, you can make a better program, and it will you will have more experience about your program and get better understanding, and you can create a better software. So thank you very much. That's my talk.
All right, thank you very much, Buffet. Okay, as usual, anyone has a question?
Yep. Who's
Raise your
gonna
hand,
ask the
please.
questions to this young man?
Yeah, quite young, younger than me. Okay.
Okay.
Okay, sir. I think you're gonna get a Grammy for the most asking question guy.
No, it's just mean high curiosity.
Someone needs to start with questioning.
Okay,
So
go ahead.
I've seen, thank you, it was a really good demonstration of the problem.
Thank you very much.
I've seen in many applications people use transaction do around everything, basically like the whole flow. So I have no idea of the implications. but I think it's slow, right? Or slower if you have transaction blocks from active record around the entire program, basically.
Right. I'm sorry. Is that your question about is using transaction will make your program slower? Is that your question?
I mean, could the solution be just to use transaction do blah 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 and around the entire code block? Is that going to solve the race condition, and is it going to make my application slower?
Well, wrapping a program inside a transaction perhaps not a good idea if we don't know how the transaction work, how the transaction works, because in SQL there's something called phantom read, and phantom read is something that you try to read a data that is being written by the other, and it can't be solved by only wrapping your program inside a SQL transaction.
Because you need to use the .lock thing, right? I've never seen that before.
Yes, lock is one of our way to
make sure no phantom read happened, right?
Yes.
Okay.
But the other thing is
Phantom
you
read.
can use isolation serializable mode, and I think that's the case.
So if I see someone doing the transaction do blah 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 blah, and next time I should tell them they are doing it actually wrong, because there can still be a phantom read.
By the way, Rails by default, since Rails 4 is reading inside a transaction and storing inside transaction. So basically, if you wrapping a transaction without any specific purpose, it will useless.
No, but you know, your example was basically what I've seen. Like you do the transaction, you start the transaction, and then you do like reading, adding stuff, and then you save, and then you're done with the transaction. So that's what lots of people, I've seen that, but they don't use .lock when they find stuff.
Yes, that's the problem.
Okay,
so we need to use the .lock.
So it's basically
with the
useless.
same ID. Yes.
Okay.
It's basically useless.
Thank you very much.
All right.
Okay, thank you.
Thank
For the
you.
next questions.
One
okay.
more question, maybe?
Okay. I have two questions actually. First is the .lock. Is that locking the whole tables in the whole table of the account?
Right.
How is that impacting the performance if we talk about like scalability problems?
So .lock in active record is only locking the specific rows. So it is row level locking, not table level or even database level.
Oh, so if you .lock .find this ID, so you only locking the rows.
Yes, exactly.
All right. And you unlock when you .save, is it?
You unlock when the transaction is done. .lock only happens inside a transaction block in active record.
So in your example, it will end on the line itself, or
Yes.
Okay.
On,
All right.
on the end of the line. Yes.
Okay. Thank you.
Okay, thank you. Maybe for the last one questions. Okay, I think it's enough.
Okay,
Okay.
so
Thank you so much.
thank you,
Mufid Afif.
everyone. Give applause.
Is it just me, or you guys also thinking that he dressed up like Steve Jobs?